In this video, we're going to model the Ribbon Chapel by architect Hiroshi Nakamura. This one has some really interesting geometry, two twisting spiral staircases that wind up and eventually meet. It's basically designed for wedding ceremonies, kind of like a symbolic path for the bride and groom. We've got some really interesting forms to practice. The spiral ramp that shapes the structure, the curtain frame wrapping around it, glass panels layered in between, and of course the stair system spiraling all the way to the top. If you're new here, this is our Rhino modeling series where we model a series of architectural buildings to help you build your modeling skills. As always, all the commands we use will show up at the top of the screen, so it's easy to follow along. Let's get started. Let's expand our front view. Here in the command field, type spiral. Set the starting axis at 0 by typing 0 and pressing enter. Now hold shift and press tab to lock it in the Y direction and set the end of the axis to 12 meters. Switch over to the top view and set the first radius to 7.5 meters. Hold shift to snap along the Y axis and click around here. Then for the second radius, we'll set 1.5 meters. So that gives us the base spiral structure. Now here in this reference image, you'll notice there's another spiral going in the opposite direction. Let's make that path. We'll use subcarve and set copy to yes. For the starting point, click right here, and the end point will be somewhere around here. With that selected, type offset. For the offset distance, click here, then move the cursor to the right. Hold shift and press tab to lock the direction, and measure the distance up to the next spiral side. Now move the cursor to the left and click again to confirm. Okay, now in perspective view, we've got the new offsetted curve, but it's in the same direction. So let's flip the direction. Select the curve and scale it in the Y direction by -1. Let's go to the front view and bring it down to ground level using the move command. Now we've got our curves flowing opposite to the spiral. We want this to continue and flow back up to the top. So let's switch to the top view, and I'm going to use blend curve. Select the first curve, then the spiral. You can choose either tangency or curvature, whichever looks better. I'm going with curvature. You can adjust the blend by dragging the control point. I'm fine with the default, so I'll leave it as is. Now jump into perspective view, and here you can see the new curve blending right back into the spiral. If you want, you can control the height by moving that middle control point up or down. Okay, looks good. Now we'll delete the earlier curve we created with subcarve, just to clean things up. Select all the curves and join them. Then rebuild, set the point count to around 180 and make sure to check Make Sub-D Friendly. Now turn on Record History. Select the curve and type Offset. We used 2.4 before, so this time we'll set half of it, 1.2 meters. In the offset options, make sure loose is set to yes and turn on both sides. Click anywhere to confirm the offset. So now it looks good. We'll enable record history again, select the first curve, the second one, and type sub-D loft. In the options, check corners and press OK. Alright, let's go into shaded mode so we can see it clearly. One thing you'll notice here is the slope. This side has a much steeper incline, while the other one is a lot gentler. We're going to fix that by making the slope uniform across the entire ramp. Use cell control point region, set the starting point here, and go up to the end right here. This is the section to even out. Now use the smooth command. Uncheck X and Y and set the smoothing factor and steps to the max to smooth only the Z direction. Repeat the same selection process with cell control point region, set the start point, then the end point. This time, don't tweak anything. Just hit enter and press enter a few times until it looks uniform. Now we've got a pretty evenly distributed slope, but of course there are still a few bumpy spots. Select the curve, invert the selection, and lock everything else. Manually sculpt by selecting individual control points and nudging them slightly up or down to even things out. We'll repeat this process across the whole surface. If there are any extra control points that aren't needed, delete them or move them around to clean up the flow. Alright, now unlock everything. Select the two offset curves, the first and the second, and extrude them upward around 2 meters. Now select that extrusion and type offset SRF. Set both sides to yes, and set the distance to 0.15 meters. Then run set object display mode and change it to ghosted, so we can see through the surface easily. So now, let's take a look at what we've got. This is how it's looking so far. A really clean spiral ramp. You can keep sculpting it by adjusting control points, but for now, let's move on to the next step, creating the curtain frame structure. Before we continue, let's clean up our layer structure. We'll start by creating a new layer called Backup, Wall, then another one named Ramp. Inside the ramp layer, we'll add 2 sublayers, one for sub D and another for curve. Next, add more layers, one for curtain panel, one for glass, one for stair. Inside the stair layer, we'll create 2 sublayers named stair block and stair top. Now let's move the appropriate geometry into the correct layers. Select the sub D geometry, assign it to the sub D layer, and hide it. Then use cell CRV to select the curve objects, assign them to the curve layer, and hide those as well. Do the same for the wall geometry, move them to their layer, and now our layers are clean. This helps us stay organized as we move forward. Let's continue with this next part, where we'll be building the curtain frame structure and the glass. Use the extract isocurve command, zoom in here, and click on the extrusion we created earlier. Make sure you're picking a point somewhere in the middle of the surface. With the new curve selected, run subcarve, set copy to no. Click here to set the start, and for the end, let's say it ends right about here, where the curtain panel system will stop. Now select the curve, invert the selection, and lock the rest of the model so we can work independently. Select that curve and type rebuild. Set the point count to 45 and make sure make sub D friendly is checked. Now extrude that curve straight up until it reaches the top level of the ramp. To make things easier to see, select the sub D and type set object display mode, then set it to ghosted so it's easier to view through. Looking at the result, some parts of the geometry have moved out of the spiral region. Hold down Ctrl+ Shift and carefully select the edges that moved out. Once they're all selected, scale them in the Y direction to flatten them, then move them down slightly. You can also manually adjust individual crossing edges. For example, this one here is sticking out. Select it, flatten it, and move it down to bring it back in line. That's it. Now we've got the base structure for our curtain panel system. Let's apply the same process on the other side. First, unlock everything. Run extract isocurve again and click on the previous extrusion. Make sure to snap to the middle of the surface. Then run subcarve again. Click here to set the starting point and set the end point around here where the panel system should stop. Select the new curve and type rebuild. Set the point count to 40 and make sure sub D friendly is still checked. Now extrude that curve downward, then scale it in the Y direction until it becomes flat and move it up until it reaches ground level. Select the new sub D extrusion, type set object display mode, and change the mode to ghosted. Now let's select the new sub D result. Invert the selection and lock everything else so we can work on this part separately. If you have unnecessary edges or tight areas, hold down Ctrl+ Shift, click an edge, and press delete. Next, Hold Ctrl plus Shift again, click the first face, then double click on the second one to select the full face loop. Let's unselect any small areas that could cause problems when we apply the curtain system. Once the faces are selected, run the inset command. Make sure mode is set to single, and for the distance, try around 0.02. You can test a few values here. For example, 0.06 works pretty well, so feel free to use that and press enter. While those faces are still selected, press Ctrl plus C to copy and press delete. Now select the remaining sub D geometry and type offset sub D. Set the distance to 0.1 and if needed, flip the direction. Press Ctrl plus V to paste the copied geometry back in. Then run offset sub D again. This time, set the distance to 0.05, turn solid off, make sure both sides is set to no, and press enter to confirm. Next, use cell last and run offset sub D once more. For this one, enable solid, turn both sides on, and set the distance to 0.02, and that gives us our curtain frame and paneling system. If you press tab, you'll see the frame collapse. Let's keep the frame as it is. Select all of the sub D we just created, unselect the top sub D, and run extract control polygon. While the result is still selected, run the toNURBS command. Next, use cell polysRF and run merge all coplanar faces to clean it up. Now, while the results are still selected, type invert, then unselect the top sub D section and press delete. If you hit tab now, the geometry stays fixed. Sub D smoothing won't affect it anymore. So now we have our curtain frame and glass structures. Also, those smaller regions we unselected earlier will now act as solid parts. Let's organize everything into the correct layers. Select the frame we just created, assign it to the curtain panel layer. Then use cell poly surface to select the glass, assign it to the glass layer, and hide that layer for now. Okay. Now we can apply the same process on this next part as well. It's just a repeat, so I'm not going to waste your time by going over everything again. You can apply the same process on the top part too. So let's jump forward a bit. By the time you finish applying the curtain paneling on the top section, you'll end up with something very similar to this. Alright, let's move on to the next step, which is creating the stairs for the spiral ramp we built earlier. So now let's enable the sub D layer. This is the ramp we created earlier. As you can see, this sub D geometry has a topology that's perfect for generating our spiral stair steps. Select the sub D object, then select the stair block layer, and right-click in the layer manager to copy the object there. Next, run the one layer on command, choose the stair block layer, and hit OK. With the sub D ramp selected, run extract control polygon. Then run toNURBS on the result, and make sure delete input object is set to yes. Now invert the selection and press delete. Select the final poly surface result and press Ctrl plus C to copy it. Then explode the poly surface and extrude it slightly upward. While the top part is still selected, run named selections and create a new selection. Let's name it top face. Now select everything and group it. With the group selected, run bounding box. Make sure cumulative is set to no, then press enter. You'll get a bunch of bounding boxes. Use cell last to grab them and group them together. Now, activate the top face. Named selection, and move it up slightly until it intersects all the bounding boxes. Then press Ctrl plus V to paste the poly surface we copied earlier, and extrude it downward until it intersects everything. Select the bounding boxes, go to Solid Tools, and run Boolean Difference. Click to select the bottom extrusion as the object to subtract from, then press Enter. Now the base of each bounding box is removed, exactly what we wanted. Let's go back to the layer structure and enable the wall layer. Select the spiral walls along with the extrusion and move them down just a bit. We want to make sure they still intersect the bounding boxes. Next, select the bounding boxes again. This time we're using Boolean split. Select both spiral walls and the extrusion. It's not letting me select the extrusion result as a group, so I'm going to run the cell group command, pick the first group, press OK, then hit enter to run the split. It might take 20 to 30 seconds, so just let it process. Once the split is complete, hide the wall layer, then select the extrusion result and move it to the default layer. Alright, now we can see the result clearly. Let's select the grouped geometry and ungroup it. Now technically, we could go in and manually delete all the small leftover parts, but that's a pretty time-consuming process. So instead, run the cell small command. This lets us select objects based on the diagonal size. Start with 3 meters as the value. Anything smaller than that will be selected automatically, but we can see some of the stair blocks are getting picked up too. So let's try again using 2.5 meters. Alright, a few small ones are still showing up, so I'll hold Control and manually deselect the pieces I want to keep. I'll Control click to deselect this one, and this one, then press Delete to remove the rest. Some valid stairs got deleted. Just press Control plus Z to undo. They'll come back with your previous selection, and this time I'll be more careful with what I deselect. Just hold Control and deselect anything you want to keep. This time, it gives us a clean set of spiral staircases. Alright, let's unhide the rest of the geometry, the walls, and the curtain frame. Now we can see there's a small gap between the spiral wall and the curtain frame. That's because we moved the spiral wall down earlier for the Boolean operations. So let's fix it. Select the spiral wall, then run the command undo selected. From the drop-down list, choose Gumball Transform and press OK. That brings it back exactly to where it was before. Now the structure looks right. We've got our stair structure wrapping along the spiral wall. Okay, it's looking solid so far. If we check the stairs reference, you'll notice that the top part of some steps sticks out slightly, almost like a little overhang or lip. That's called stair nosing, and that's what we're going to handle next. Let's make a copy of our stair blockers. First, go to the stair block layer. Right-click and choose Select Objects. Then select the stair top layer, and right-click on the layer manager. That will make a copy on the selected layer. Now run the one layer on command, select stair top, and press OK. It will isolate our copied stair block. With that done, press Ctrl plus A to select everything, then explode it. Type cell planar SRF, invert the selection, and press Delete. That leaves us with the top faces and some vertical ones. We only want the flat top surfaces, so let's clean up the verticals. Run cell small and test it with a diagonal value of 2.3 meters. Some horizontal parts still get selected, so try 2.2 meters instead. A few flat faces still get picked. Hold Control and unselect the ones you want to keep. Once only the vertical surfaces are selected, press Delete. Next, run dup border, select all the surfaces, and press Enter. With the border selected, type offset multiple, set the distance to 0.05, and click outside to confirm. Now, run cell last to select the new offset surface and run planar SRF. Run cell last once more, invert the selection, and press Delete to remove the rest. With just the new surfaces left, press Ctrl plus A and run extrude SRF. Set the distance to 0.05 meters. Now unhide the stair block layer. There we go, stair nosing is now added to the top of our steps. Let's unhide everything else too, like the walls and the curtain frame. And that gives us our final result. Here are some quick renders I made using the model we built so far. If you found this tutorial helpful, give the video a thumbs up to let us know you'd like this series to continue. I'll leave you a YouTube playlist over here, so you can check out similar content like this. You'll definitely find some useful modeling techniques as well. Thanks for watching, and I'll see you there.